Hello! Today we will conduct a laboratory work illustrating the reducing properties of halides. These experiments are useful for preparing for the exams. They allow you to compare the behavior of substances containing elements of the same group of the periodic table. We will conduct experiments using VRChem Lab, a virtual chemistry lab available in both VR and the web. To compare the reducing properties of halides, we will be adding concentrated sulfuric acid to different solid halides. For this, we need solid salts, potassium chloride, bromide and iodide, as well as concentrated sulfuric acid. It should be noted that this experiment is rarely carried out in class, since it's dangerous to work with concentrated sulfuric acid, and the gases released during the reaction are toxic. There is no danger of poisoning in the virtual laboratory. The VR laboratory has developed a gas analyzer that determines and shows the properties of the evolved gas using indicators. Determination of the acid-base properties of the gas is carried out by demonstrating the color of methyl orange and phenolphthalein, as if we held the appropriate indicator paper to the neck of the reaction vessel. Determination of the reducing properties of the gas is carried out by demonstrating the color of the paper would have had been moistened with a solution of potassium permanganate after being brought to the neck of the reaction vessel. If you put an empty flask into the gas analyzer, the color of the indicators will correspond to their color in air, that is, in a gas that does not have acidic, basic and reducing properties. We will carry out reactions in flasks. We will take solid salts from jars using spoons. Potassium chloride reacts with concentrated sulfuric acid to produce a colorless gas. This gas dyes the methyl orange indicator red, does not dye phenolphthalein, and discolors the permanganate. Hence, it has acidic and reducing properties. This is hydrogen chloride. Let's move on to the next experiment. Put potassium bromide in an empty flask and add sulfuric acid. The bromide reacts with concentrated acid to form an orange solution and gas. The gas has acidic and reducing properties. By the color of the gas in solution, we can assume the formation of bromine, and by the acidic properties of the gas, the release of sulfur dioxide. Carry out the same reaction with iodide. Put the solid iodide back into the flask and add acid. We see the formation of a dark solution and gas evolution. By the color of the solution, we can conclude that iodine is formed. Although the main gas product of the reaction is hydrogen sulfide, sulfur dioxide is formed as a result of a side process. It is worth noting that in a real experiment, the reaction of potassium iodide with concentrated sulfuric acid is accompanied by the evolution of a gas with acidic properties. No redox processes occurred in the reaction of concentrated sulfuric acid with chloride. In the second case, the bromide was oxidized to Br2 and reduced sulfur from the oxidation state +6 to +4. Iodide also oxidized to I2, and sulfur was reduced deeper to -2. It can be concluded that the reducing properties in the series chloride-bromide-iodide increase.